Hello, everyone. In our last lesson, we learned about the automatic construction of coordinate systems. In this lesson, let's continue with CNC mill parts as an example to complete the automatic measurement and dimension evaluation of features that are related in size requirements. PCDMIS offers automatic measurement functions for common and typical features. During this task, we will successively use functions such as automatic plane measurement, automatic circle measurement, automatic cylinder measurement, automatic cone measurement, and automatic sphere measurement. Compared to manual measurement, its greatest advantage lies in a more rational distribution of feature points, which better reflects the actual machining precision of the workpiece. Through this lesson, I hope you can become proficient in using PCDMIS software's functions for automatic plane measurement, automatic circle measurement, automatic cylinder measurement, automatic cone measurement, and automatic sphere measurement to accurately measure the typical features of CNC mill parts, and learn how to conduct dimension correlation analysis and evaluation. Next, let's take CNC mill parts as an example to specifically learn about the automatic measurement of features and dimension evaluation. After establishing the coordinate system, feature measurement can be performed. In automatic mode, automatic measurement features are required. Click Insert, Features, Automatic to select the type of feature you want to measure. Next, let's perform automatic measurements for each feature according to their distribution. First, the first dimension is the distance between two planes, with associated features being reference plane C and plane 1. Since reference plane C has already been touched off previously, here we only need to touch off plane 1. Before touching off, it is also necessary to add moving points at a safe position, i.e., the process moving from reference plane C to plane 1 requires adding moving points. After adding the moving points, touch-off can be performed on plane 1. The second dimension is the distance between a plane and the central axis of a cylinder, with associated features being reference plane B and cylinder 0121. Similarly, since reference plane B has already been touched off previously, here we only need to touch off cylinder 1. First, add moving points at a safe position. Then insert Features, Automatic, Cylinder, and select the corresponding cylinder. In the pop-up dialog box, enter the cylinder feature parameters. First, change its name to CYL1. Ensure that you check if the center coordinates are correct according to the drawing, and input its diameter and length. Click Show Touch-Off Points to view the touch-off path. When touching off the cylinder, it should be done in at least 3 layers, with at least 4 points per layer, modifying their depth and in-depth accordingly. In the touch-off automatic movement properties, select both, with both pre- and post-distances set to 10. Click Create to proceed. Check the running path to ensure there is no collision before moving on to the next step. The third dimension is position tolerance. The related measurement features are reference planes A, B, C, and the threaded hole M10. First, add moving points at a safe position, ideally directly in front of the hole. Then click Insert, Features, Automatic, Cylinder, and select the corresponding position of the M10 threaded hole. Similarly, check if the center coordinates are correct, if the diameter and length inputs are accurate, review if the touch-off path is reasonable, and check if the touch-off automatic movement properties are set to both. If everything is confirmed to be correct, click Create. Also, review if the running path is correct and reasonable. After confirming there are no issues, you can proceed to the next feature measurement. The next dimension evaluation is for the cone angle, with the associated feature being cone 1. First, add moving points at a safe position as well. Then click Insert, Features, Automatic, select the cone, rename it to CON1, and check if its parameter settings are reasonable. Once you confirm that the parameter settings are reasonable, click Create. Similarly, review its running path to ensure there are no issues such as collisions. The next dimension evaluation is the distance between a plane and a cylinder, with the associated features being reference plane C and cylinder 0121. Since both associated features have already been touched off, there is no need to perform further feature touch-off here. The sixth dimension is for parallelism, with the features being reference plane A and plane 2. Plane 2 faces the negative direction of X, so here we need to change the probe angle. Before changing the probe angle, move the probe to a safe position. Therefore, add moving points here. After adding the moving points, touch-off can be performed on plane 2. Review its running trajectory to ensure there are no collisions or interference during the process. Through today's lesson, We have mastered the automatic measurement methods for typical features in PCDMIS and learned how to perform dimension correlation analysis and evaluation. Automatic measurement technology, with its efficiency and accuracy, provides us with strong support. In future studies and work, I hope you can flexibly apply these techniques, continuously improving your professional skills and levels. Finally, please reflect on this lesson and complete the following exercises to consolidate the knowledge you learned today and deepen your understanding. This concludes our lesson. See you next time.